Welcome back, smart solvers, to Ganitagya Gyanam, your destination for concept clarity and gate success. Today, we are going to discuss very important three questions from Instrument Engineering Gate 2025. In the first question, we are going to find the integral of minus pi to pi cos raised to power 6x plus cos raised to power 4x dx. We are going to apply here the three formulas one by one. How we are going to use those formulas? Let us discuss. First formula that we are going to discuss over here is the integral from minus a to a f of x dx, that is equals to twice of integral from 0 to a f of x dx if your function is even, means that f of minus x is equals to f of x. Integral from 0 to 2a f of x dx is equals to twice of integral from 0 to a f of x dx if f of 2a minus x is equals to f of x. And the third formula, that is known as the reduction formula, that we are going to use over here for the integral 0 to pi by 2 cos raised to power n x dx, that is equals to n minus 1, n minus 3, n minus 5, so on, divide by n n minus 2, n minus 4, again up to so on. We are not going to write negative or zero value over here, and it is multiplied by pi by 2 if your n is an even number. So how we are going to use these formulas in this integral? Now the integral that is given to you is from minus pi to pi f of x dx. Here f of x is your, that is cos raised to power 6x plus cos raised to power 4x. As we know that cos function is always an even function. So if it is an even function, then we can write this integral, that is from 0 to pi f of x dx. Now how we are going to use the second formula, that is from integral 0 to 2a. Here 2a is f. So for applying the second formula, let us discuss first its condition, that is f of pi minus x if it becomes equals to f of x. Now what is your f of x? F of x over here is cos raised to power 6x plus cos raised to power 4x. So let us change x as pi minus x. So cos pi minus x whole raised to power 6 plus cos pi minus x whole raised to power 4. Now cos pi minus x means it is in a second quadrant, and in second quadrant cos is negative, so minus cos x raised to power 6 plus minus cos x raised to power 4. So if it is an even power, then we can write it as it is cos raised to power 6x plus cos raised to power 4x, and that is equals to f of x. It means this value we are going to write equals to 2 is already there, 2 into 2 0 to half of the a, means 2a becomes a, so here pi becomes pi by 2 f of x dx. Now we are going to apply the reduction formula, third formula. So that is 2 into 2, that is integral from 0 to pi by 2 cos raised to power 6x dx plus 0 to pi by 2 cos raised to power 4x dx, right? So that is equals to 4 into, we are going to apply here 6. 6 minus 1 is 5 into 3 into 1 over 6 into 4 into 2 into pi by 2. Okay, so let us multiply 4 on both sides. So plus 4 into, now 4 becomes 3 into 1, 4 into 2 into pi by 2. In both the cases, both the terms, we apply the reduction formula. So here 3 2s are 6, 4 4 cancel. So we left with 5 by 8 pi plus. Here 4 4 cancel, so 3 by 4 pi. Take LCM 8 and take pi common. So 5 plus 6, that is 11 by 8 pi. 11 by 8 pi. So let us see which option is this one. This one is the C option. So we are applying over here three formulas, and just these three formulas we are going to apply, and this one is the simplest method as compared to the other procedures. So agar concept clear, to sub clear. Now in the second question, choose the correct statements from the following options regarding Cauchy's theorem on complex integration, where C is a simple closed path in a simply connected domain D. Okay, so we have to correct option, we have to choose by using the Cauchy's theorem. And what is a Cauchy's theorem? If f of z is analytic, if f of z is analytic in a simply connected domain D and C is a simple closed curve in a D, then the integral on f of z is 0. So first A option is Cauchy's theorem cannot be directly applied to conclude that f of z dz equals to 0 when f of z is equals to 1 by z square and C is a unit circle. Now given function is 1 by z square. Function is given to you 1 by z square. So it is not analytic at z is equals to 0. So we are going to apply the here the residue theorem. So residue theorem is the integral of f of z dz is equals to 2 pi iota summation of the all the residues. So that is equals to 2 pi iota. Now what will be the residue? Let us find out here. So residue at z equals to 0, that is limit z approaches to 0 because your pole is at 0. Then derivative with respect to z square into 1 by function z square. So it is cancelled, derivative of 1 is 0, so that is equals to 0. So it means your residue 0, 2 pi iota into 0 is 0. So this integral becomes 0. Directly, we can't apply the Cauchy's theorem because here it is not analytic. But using the residue theorem, we can show that its integral becomes 0. So option A is the correct option. Second option is if f of z is analytic in D, then it can be concluded that integral is equals to 0 for any simple closed path C in a D. Yeah, that is the Cauchy's theorem. So if function is analytic in domain D, then the integral becomes 0 in or within the circle, closed path. The C is the function f of z must be analytic, right? If function is analytic, then we can conclude the integral is 0. That is again correct. Last option, integral f of z is not equals to 0 when f of z is equals to z square, since the function is not analytic. Now if A is correct, then D can't be correct because here we already proved that the integral becomes 0 by using the residue theorem. So option D is wrong option. So according to this, we can say A, B and C, three options are correct options in this question. Now the last question that we are going to discuss over here is the probability of a student missing a class is 0.1 in a total number of 10 classes. So total number of classes are 10. So to miss a class, that is the probability of success is 0.1. So its failure is 0.9. We have to find the probability the student will not miss more than one class. So it means will be the 0 means he is not going to miss any class, or at class means not more than means minimum 0 or 1, that's all. So we are going to apply the binomial theorem. So here n is 10, c naught 0.1 raised to power 0, 0.9 raised to power 10 plus 10 c1 0.1 and 0.9 raised to power 9. So simplify it. So 1 into 0.9 raised to power 10 plus 10 into 0.1 into 0.9 raised to power 9. So if you are going to simplify it, it gives you 0.7361, but we have to round off two decimal places, so it becomes 0.74. So the correct value is 0.74. So if you are finding this helpful, don't forget to subscribe Ganitagya Gyanam. So don't forget to like, share and subscribe. Concept clear to sub clear. Goodbye and take care.